I'm going to see how much of this I can fit into about 10 minutes, because that's the kind of time frame I'm looking at right now. But I've been thinking about the universe, like the entire universe, and how we're all thinking of it slightly wrong. Because obviously, I don't know how you personally are thinking about it, but from what I understand, most people are thinking about it as an explosion that has already happened, and we're in the aftermath, which is completely wrong. Or people are thinking of it as an explosion that we are part of right now, which is more correct, but still not correct. But that's because there is no completely correct model yet, if there ever will be, because we're trying to fit all of space and time, matter and energy into an idea, and that doesn't really work. So, I've been thinking of it as a puzzle, and it's the most unique and difficult puzzle possible, because the easiest mode is building it from the atomic scale, which means there's 10 to the 83rd power number of pieces, because that's the rough number of atoms in the universe. You have to build it in a 3D model, and what you're building is changing in faster than nanoseconds. Whatever the PT second thing is, I don't remember what it's called, but it's like the smallest observable amount of time is 12 of them or something. And how if you were doing it on a bigger size, the picture would remain more stable, but be less accurate because of how relativity works. Because if you want like the actual picture, you have to do it on the atomic scale. Well, strictly speaking, you have to do it on the quark scale. But the atomic scale would be easier, because there's 6 quarks, or there's minimum of 3 quarks per atom and stuff. But the picture would theoretically be more stable if you use the bigger one, because of how relativity works. To us, on what amounts to the micro scale, the universe looks like it's constantly moving and changing. We can see the expansion of the universe from the Big Bang, but if you're looking at the universal scale, it's not moving, because what is moving is so small, you won't be able to see it. It's like how if you're standing at the base of Mount Everest, the mountain's not moving, it's a mountain. They don't get up and walk away. But if you're on the International Space Station, you'll be able to see the mountain moving around a fixed point, which is the center of the Earth, or well, the rough center of the Earth. I think due to its height, it's a little bit off. It is some angle shit. And you'd be able to see that moving. And then if you're outside of that, outside of our solar system, you'd be able to see the point that is the center of the Earth moving around a different point, the center of the sun. And if you're outside of that, you'd be able to see the center of the sun moving around the galactic center. If you're looking at that, you look at superclusters moving around each other, pulling us closer to Andromeda at a very slow rate. To the point where if you were looking at it at that scale, you wouldn't see it moving. Because relativity means that at a small scale and at a large scale, you can't see the movement. Because at one point, you're too far away to see any actual movement, and at the other, you're too close to see any actual movement. You have to be at a relative point, separated from everything else. Thus the name relativity. But this is what makes trying to conceptualize the universe so hard, because we're too close to the micro side of the relative point that we see the universe moving around us, kind of. We see the after effects of the universe moving past us. And so that we know that the universe is moving. But if we were any smaller than we are, we wouldn't be able to tell it. And if we were much larger than we are, solar system size or bigger, we wouldn't be able to see it. Which means if you were to go with my puzzle idea, you would have to do it from the atomic scale, because that's the point where everything is moving. But you would build it into an unmoving picture that's changing, which is something that's very hard to wrap your head around, because it's a perfectly still image that is changing in 4 dimensions simultaneously. And this is also why the universe doesn't have an origin point. Like, there is no one, this is where the universe started point. Because the universe is still technically at that point. It hasn't moved enough on the universal scale to be outside of that point. But on everything smaller than the universal scale, it is away from that point. Except it's not, because it's still there. So trying to look for the center of the universe, or the starting point, or whatever, doesn't work, because we are both in it and outside of it simultaneously. So it's this kind of Schrodinger's cat of this both is and isn't the center of the universe at all times. Because, like I said, we can see that the universe is moving away from everything else, but it's also not, because it's too big, because it is everything else simultaneously. So you've got this weird contradiction that we are too small to understand, and if we were big enough to understand it, we'd be too big to see it. But yeah. So you're thinking of the universe wrong. Sorry if this gave you a migraine or made your stomach hurt. And none of them is inherently wrong, but I'll get into that later. Thanks for listening, if you've been listening.